Fortunately, most of the remaining wildlands and their carbon sequestering ecologies do lie in the south. But water is the most salient feature of the south, and water absorbs a lot of CO2 and a lot of heat. Water is a heat sink because of what is called its enthalpy. Wiki's entry on ocean heat content tells us, quote, in oceanography and climatology, ocean heat content, OHC, is a term for the energy absorbed by the ocean, which is stored as internal energy or enthalpy. Changes in the ocean heat content play an important role in sea level rise because of thermal expansion. Ocean warming accounts for 90% of the energy accumulation from global warming between 1971 and 2010. And about 1/3 of that extra heat has been estimated to propagate to a depth below 700 meters. Beyond the direct impact of thermal expansion, ocean warming contributes to increased rates of ice melt of glaciers and fjords of Greenland and ice sheets in Antarctica. Warmer oceans are also responsible for coral bleaching, end quote. Now think about it. The Southern Ocean is the world's most massive heat sink, and it picks up most of that heat because it has a vast surface area exposed to the sun, unlike the thermal mass of land, which experiences relatively rapid adiabatic heating and cooling. The ocean stores the heat for much longer and releases the heat much more slowly. In addition, water vapor itself is a powerful heat-trapping gas. So what happens when you cover the planet with other greenhouse gases that trap the heat? The net effect is to keep the warming going for much, much longer. And any change to the ocean heat content exchange in the Southern Ocean has profound effects on the entire planet. Says NASA, quote, the most important mechanism is latent heat release or evaporation. Over the ocean, latent heat is the engine that drives atmospheric circulation.